Okay, on to science in context. The first part of the section talks about where do scientific ideas come from and what kind of attitudes lead scientists to come up with these new ideas. The first one is a natural-born curiosity. Scientists by nature are curious and understand that results from previous experiments give us new ideas that give us to new questions and wonder why. The second thing is that scientists also have a healthy dose of skepticism. They never believe it until you show them. Kind of like they say people from Missouri, we're the show me state. So you have to, I'm not going to believe it until you show me. So they will question the existing ideas and always have to have that hard evidence, that data. Scientists also are open-minded. They are willing to accept when they are wrong or their hypothesis is disproven when new ideas or new data comes along. So we're all open to new ideas. And the last part is scientists are actually very creative. Sometimes people don't think scientists are creative, but sometimes researchers need to think kind of out of the box to come up with new ideas and design experiments to yield that accurate data that we're looking for. Scientific methods are very closely linked to exploration and discovery. So our methods are linked to exploration and discovery, which is what we talked about, scientific method. But the rest of this lesson is going to be talking about how scientists communicate results and also how science is related to science to society. With exploration and discovery, we talk about the role of technology. Technology is not just involved what you think of in terms of computers, but it's also how we are trying to apply science to help solve practical problems. So some sort of new problem comes along, and scientists begin to the process of scientific method to get new questions, new hypotheses, and new experiments to come up with a way to solve this new problem. Technology is simply an application of science in some way to give some practical problem. Okay, there we go. One important idea in science is that not only do we come up with experiments and test them, but we need peer review. Peer review is important because it is when we share articles in a journal to come and test and evaluate other scientists' work. So publishing in an article in a journal allows other scientists to see what we're doing and to also evaluate what's going on. So what exactly is peer review? While scientists will publish articles that have undergone this process, once they have completed their experiment and written a conclusion and all of that, they are reviewed by anonymous and independent experts, so an expert in the field. So we wouldn't have an expert in astronomy, the stars, reviewing an article written by a biologist about DNA. So we'd use an expert in your field. What are these reviewers looking for? Well, they're looking for four main things. They're looking for an oversight, something that we did not, we missed some important little facts. They're looking for unfair influences. Did we use our own personal beliefs or feelings to influence the results? Looking for fraud, people who are trying to lead scientists in the wrong way, and also a mistake in the technique of the actual experiment or in reasoning. So why do we need peer review? It helps to ensure that all scientists meet high standards of quality so that everybody's articles are of high quality. Whoops, missed one. Part of the sharing of new ideas and through peer review is helping to spark new ideas. Anyone who has a new idea or a new question can, from reading your experiment, could lead to a new hypothesis, but that new hypothesis then, of course, has to be independently controlled, a new experiment. So we talked about scientific method and hypothesis and experiment and collecting data and drawing a conclusion, but now we'll move into what is a scientific theory. And this is a word you've probably heard a lot before, but sometimes it can lead to a little confusion. A scientific theory is a well-tested explanation that gives us a broad explanation of many different kinds of observations and hypotheses. So it helps scientists make accurate predictions about new situations. So it gives us predictions, enables us to predict new situations. It is supported by many kinds of evidence. So many different types of evidence or data helps to support a theory. No theory, and I say no theory, is considered to be absolute truth. All scientific theories can be revised or replaced by something that is more useful or more correct. So when new data comes along, theories can be revised. That doesn't mean new data always comes along, but it can come along. Now moving on to science and society. So looking at what is the relationship between science and society. We must understand that science has limitations. And how does science fit into our society? Scientific questions not only involve just the science knowledge we're seeking to gain, but it also involves the society where we live. It involves our economy. How much money do we have to pay for the science research? And also laws that are currently in place, and moral principles. Just because we can doesn't always mean we should. So pure science does not include any ethical or moral viewpoints. We're simply satisfying curiosity or building knowledge with pure science. But then we continue on and develop technology to help address our problems or issues that we have, but that does not necessarily apply and tell us that we should use it. Just because we can doesn't always mean we should. Oh, there we go. Now, bias is kind of the last part here of this section, and what is bias? The word bias is that a scientist uses his particular preference to an idea or a point of view that would be a personal ideas rather than based on purely scientific facts. This becomes a problem because science aims to always be objective, always simply based on the facts or the evidence and not our own point of view. Data, while data is very factual, the conclusion or the analysis that we work toward after a experiment can be misinterpreted or misapplied by scientists who are trying to skew or sway people toward their particular point. You have to be really careful with scientists, with science in general, because recommendations that are made by scientists showing bias, where they may have misinterpreted or misapplied the data, may or may not be in the public's best interest. And this is why it's important to be scientifically literate or have a good understanding of science, so that you can be aware and be informed when some science scientists may show bias of some sort. And that's the end.